This video introduces truth tables for SL. Consider this sentence, parenthesis z arrow z, close parenthesis, biconditional parenthesis z or not z, close parenthesis. Is it true or false? Well, it depends on whether z is true or false. When we're translating using a particular symbolization key, it makes sense to ask that. If z means zebras have stripes, we can ask, do zebras have stripes? And yes, it's true that they do. Knowing that z is true, we can use the truth function for each connective to calculate the truth value for the whole sentence. Here's a reminder of how each connective works, given its characteristic truth table. Remember, though, that z is an atomic sentence. As a symbol of SL, it's just a switch that can be in one of two positions, true or false. The two positions could just as easily be called on or off, 1 or 0. So we're going to do truth tables using ones and zeros. The point here is partly conceptual. As a formal matter, the truth values are just two possible values. Each sentence letter is one bit of information. It's also partly practical. It can be hard to tell the difference between a sloppily written T and a sloppily written F, but ones and zeros are just easier to read. Since Z might not be about zebras, it might be about anything at all we can say is that it's got a value of 1 or 0. So we start the truth table with two rows, one for each possibility. If Z is true, then it's true everywhere that it shows up in the sentence. So Z has a value of 1 on the first row. And on the second row, it's got a value of 0 everywhere it appears in that row. We focused on the smallest parts first, like not Z. It gets a value of 0 when Z gets a 1, and 1 when Z gets a 0. Now that we've calculated the value for not Z, we can combine it with the value of Z to get a value for Z or not Z. It gets a 1 when it's 1 or 0, and it gets a 1 when it's 0 or 1. Now we can go over to the left-hand side and calculate the conditional, z arrow z. 1 arrow 1 gets a 1. 0 arrow 0 gets a 1. If you don't have these functions memorized, that's okay. The tables from earlier in this video are in the textbook, both in Chapter 3 on page 26 and in the appendix on page 150. Now that we've done the two sides of the biconditional, we can do the biconditional itself. Both rows are 1, biconditional 1, which gets a 1. That's the complete truth table. The value for the whole sentence is underneath the main logical operator. Everything else, which I've grayed out on this slide, was just record keeping. What we've learned is that this long sentence gets a value of 1 regardless of what the value of Z is. That is, it's true regardless of whether Z is true or false. Now consider this sentence. If E and F, then F. Again, whether it's true or false depends on the truth value of its atomic parts. But here we have two atomic parts. We've got E and we've got F. There are two sentence letters and 4 possible combinations. We start by figuring out the value for E and F. And because of the way we've set up the table, it looks exactly like the characteristic truth table for conjunction. Note, we could have copied over the values for E and F. And in these spaces I've marked on the slide. If you want to do that, that's fine. But it's really just extra bookkeeping. Because now we need to determine the value for the conditional. And that just looks at the value for the conjunction and for F. So 1 arrow 1 gets a 1. And 0 arrow 0, 0 arrow 1 also get 1s. So we've determined the truth value for this sentence in all 4 possible situations. And in every possible situation, it got a value of 1. Now consider this sentence. Either not A or D, or not D or J. This has 3 sentence letters, and so there are 8 possible combinations. Again, we have to start with the smallest parts. We have to start with one of the negations. So for not A, we're just looking over at the A column and taking its negation. For not D, we look at the D column and take its negation. Now we can do not A or D. The disjunction gets a value of 0 only where both disjuncts have a value of 0. That's the 3rd and 4th row. And it gets a 1 on the rest of the rows. On the right-hand disjunction, it follows the same rules, but we're looking at different columns. We're looking at the column for not D and the column for J. And we fill in 0 only where both of those have values of 0, and it gets values of 1 everywhere else. We're now in a position where we can do the main logical operator, that is, the disjunction in the middle. Here we look, and in the 2 columns we're looking at, there aren't zeros together on the same row, so it gets a 1 all the way down. So we have this complete truth table for the sentence. Again, the column that matters is the one underneath the main logical operator. All of the columns that I've grayed out were just things that we calculated as a matter of bookkeeping, as a calculation device along the way. Now consider this sentence. Either, if not M, then N, or it is not the case that Q and not P. How long would a complete truth table be for this sentence? Well, we know that when we had one sentence letter, there were 2 possibilities. It could be true or false, 1 or 0. So the complete truth table for a sentence that has only one sentence letter in it is 2 rows. For a sentence that has 2 sentence letters, each of the sentence letters has 2 possibilities, and that makes for 4 possible combinations, and that means 4 rows are required. A sentence with 3 sentence letters makes for 8 possible combinations, and that means the complete truth table requires 8 rows. Now, with 4 sentence letters, there are 16 possible combinations, so the truth table requires 16 rows. In general, a complete truth table with n sentence letters requires 2 to the n rows. Since I could barely fit 8 rows into this video, I'm not going to try stepping through a truth table with 16 rows. The important point is that the bigger truth table isn't conceptually any different than the smaller truth tables we've already done. Okay, I can't resist. Even though I'm not going to step through it, there's nothing new or tricky in this 16-line truth table. You might want to pause the video and think through this one. Once you can do small truth tables, you can do bigger ones. It's just more of same. A 16-row truth table is not really any more complicated than 2 8-row truth tables stacked one on top of another. And the same holds for 32, 64, or 128 rows. In the next video, we'll talk about using truth tables, for example, to test whether a sentence is a tautology or whether an argument is valid.